Today, I will be talking to you about how to run an analysis of variance or one-way analysis of variance, ANOVA test, and post hoc test. More specifically, we will be looking at the one-way analysis test as well as a Fisher's LSD test. The ANOVA is used to compare the means of three or more independent groups. We will begin by selecting our SPSS program and opening the program to access the data that we have prepared. For the purpose of this test, we are using third grade scaled scores from the Scantron Reading Performance Series Assessment. We will access this data by opening a prepared spreadsheet. As you see, I have two columns, my subpopulation. For the purpose of this test, we are only focusing on three main subcategories. The numeral 1 represents Black and African American students. Numeral 2 represents Hispanic Latino subpopulation. And numeral 3 represents our white subpopulation. Column 2 shows the scaled score for that subpopulation for each student tested. Before I run my test, I must look at my variable view. I see that I need to change the score type to a numeral or numeric variable type. And I also want to alter my decimal column to represent 2 decimal places. I can verify that through my data view, and I see now that my data is ready to run the first test. The ANOVA is used to compare the means of 3 or more independent groups. In an experimental design, this tests the causal effect of an independent variable with 3 or more levels of a dependent variable. In a correlational or a quasi-experimental design, this examines the relationship between the grouping variable and the measured variable. We will begin to run our ANOVA test. Click on the tab Analyze, Compare Means, and One-Way ANOVA. Here we're presented with the option of moving our 2 columns into dependent lists and factors. For the purpose of this test, our subpopulation will be our independent variable, and our score will be our dependent variable. Click on Options, and we can choose the reports to be run: Descriptive and Homogeneity of Variance Test. Click OK. Now we have our output for the tests that have been run. Using the data, we see that I have run assessment data for approximately 119 African American or Black students with a mean of 23.29. I see that I have run the assessment data for 69 Hispanic or Latino students with a mean of 21.98. And I see that I have run the data for 122 white students with a mean of 31.06. You will use this table to report any descriptive data. Scrolling down to the next data box, this information represents the test of homogeneity of variances. The value of your test statistic is seen in this first box, 12.852. The last box shows you the significance and tells us whether to reject the null hypothesis or not. If the test of homogeneity of variances is less than 0.05, we cannot use the parametric test or the ANOVA. Here you see the significance is 0.000. Therefore, we reject the null and will run a secondary test or a non-parametric parametric test. To run the post hoc test, I will minimize my output window and return to the data window. Nothing is lost. All data and output results will remain, but I will add one additional test. Post hoc test is the name that is given to a statistical test which we run if our ANOVA test indicates that there is a statistical difference among the groups or an overall difference. It will tell us which groups are significantly different. There are numerous tests that you can choose from, but for the purpose of this video, we will choose our Fisher's Least Significant Difference or LSD test. Let's begin. Click on Analyze, Compare Means, and One-Way ANOVA. Our dependent and factor remain the same. This time we'll choose the second box for post hoc and select our LSD test. You see that your significance level is defaulted to 0.05 and continue. OK. The Fisher's Least Significant Difference, or LSD test, computes the smallest amount that group means can differ in order to be significant. Our output window has been updated. Our descriptives window remains the same, as does our test of homogeneity of variances and our ANOVA window. Now we have data represented in our post hoc test, showing multiple comparisons of each subpopulation. We see the comparisons of our African American or Black subpopulation to the results of our Hispanic Latino and white subpopulation, as you see in rows 2 and rows 3. Looking at the data, it can be determined that by third grade, white students on the Scantron reading assessment was statistically significantly higher than that of African American peers, with a significance of 0.000, as well as Hispanic Latino peers represented by 0.000. There was no statistical difference between the African American student population and performance of Hispanic Latino third grade students, as we see the significance is 0.251 and is higher than the 0.05 significant level. Today we have run the ANOVA and post hoc Fisher's LSD test.